Yeah, good afternoon, students. Yeah, I hope I am visible and audible to all of you. Yeah, fine. So let's start with the class. So yesterday we have seen the mole concept and stoichiometric part of this lesson. And in that we have seen several things, and at last we have seen the concentration terms, right? So what is meant by concentration? It is the quantity of solute present in a given quantity of solution. So it is called as the concentration, and it can be measured in 4 ways. It can be measured in 4 terms. Okay. So one is mass percentage, and the other one is mole fraction. Third is molarity, and the fourth one is molality. So yesterday we have seen what is mass percent and mole fraction. So what is mass percent? It is equal to the mass of solute is equal to the mass of solute by the mass of the solution, total mass of the solution into 100, right? And coming to the mole fraction, it is represented by the letter chi. And if I want to measure the mole fraction for the component A, then Xa will be number of moles of that component divided by the total number of moles. If the mixture is binary, then it is Na plus Nb. So these are the 2 formulas we have seen for under concentration. Now, in today's class, we will start with the third term, that is molarity. So what is molarity? Molarity is the number of moles of solute present per liter of solution. Okay, number of moles present in 1 liter of solution is called as molarity, and it is represented by capital letter M. Okay, so it is equal to number of moles of solute by volume of solution in liter, which is very, very, very important. Molarity is very, very important, and the unit of molarity is mole per liter. It is for the number of moles in volume, right? So it is mole per liter. Very important formula, you have to keep it with. Then coming to the next, for dilution of solution, if I am going to dilute my solution, suppose initially I'm having a solution and the molarity is M1 and the volume is V1. Now I'm going to add water to the solution. On adding water, so the volume will increase, right? But the number of particles present inside the solution remains same. So now the molarity becomes M2 and the volume becomes V2. Now we have one relation like M1 V1 is equal to M2 V2. Clear? So if I am diluting the system, then M1 V1 will be equal to M2 into V2. Now using this molarity formula, we will solve one question. So calculate the molarity of aqueous NaOH solution prepared by dissolving 4 gram of NaOH in enough water to form 250 ml of the solution. So what is given in the question? So it is a sodium hydroxide question, and the 4 gram is the mass of sodium hydroxide, and 250 ml is the volume of sodium hydroxide solution. Okay, it is given in terms of milliliter. Now we have to find out the molarity. So what is molarity? Molarity is equal to number of moles of solute divided by volume of solution in liter. We have volume, we can convert this milliliter to liter, but we don't have number of moles. So what is the formula to find out the number of moles? Number of moles is equal to the given mass divided by molar mass. The given mass divided by molar mass. So the given mass is 4 gram and the molar mass of sodium hydroxide is 40. Because for sodium, the atomic mass is 23, and for oxygen, it is 16, and for hydrogen, the atomic mass is 1. So if you add all these, you will get 40. So 40 is the molar mass of sodium hydroxide, and when we divide this, we are getting 0.1 mole as the number of moles of NaOH. Okay. Now we have got the number of moles value, as well as we have got the volume. Okay, if you convert this into liter, it will be 0.25 liter. Now substitute these two values in the formula. Molarity equal to number of moles by volume of solution formula. You substitute, we will get 0.4 mole per liter as the molarity for the aqueous NaOH solution. Okay, so It is very easy. You just need to find out the given values and you need to identify what is being asked and what is required to solve the question, and accordingly use the corresponding formulas and then go with the answer. Okay. So this is the third term. Now let's move on to the fourth term. The fourth term is molality. So what is molality? It is defined as the number of moles of solute present per kilogram of solvent. Per kilogram of solvent. Okay. So the difference between molality and molarity is their volume of solution in liter and here mass of solvent in kilogram. That is the only difference. Okay. Molality is denoted by the letter small m. And the unit, if you see, it is mole per kilogram. And the formula says that number of moles of solute by mass of solvent in kilogram. So the molality formula is also very important, like molarity. Okay. The numerator remains same for both. Only the denominator differs with volume in molarity and mass of solvent in case of molality. Clear? Now, using this formula, we will solve one question from molality part. So, let's go with the question. The question says that calculate the molality of calculate the molality of 2.5 gram of ethanoic acid in 50 gram of benzene. And the molar mass of ethanoic acid is 60 gram per mole. So what is the formula to find out the molality? Molality is equal to number of moles of solute divided by mass of solvent in kilogram, right? Mass of solvent in kilogram. It is the number of moles of solute by mass of solvent in kilogram. So we have the solvent is benzene. Okay, the solvent is benzene and the solute is ethanoic acid. So what is given in the question? The mass of solute is given and the mass of solvent is given. We have to find out molality. So mass of solvent we have in the question, but have the number of moles. So to find out the number of moles of the solute, what we need? We need, what is the formula first of all? To find out the number of moles, it is given mass divided by molar mass, right? The given mass of the solute is 2.5 gram. It is there in the question. And the molar mass of the solute, molar mass of ethanoic acid, we have to calculate. How to calculate? How many carbon we have? We have 2 carbon. So 2 into 12, it will be 24. And we have 4 hydrogen. So 4 into 1 is 4. And we have 2 oxygen. So for 1 oxygen, atomic mass is 16. Since we have 2 oxygen, it will be 2 into 16, that is 32. So we will have 60 molar mass of this ethanoic acid. Okay. And on solving this, we are getting 0.0417 mole as the number of moles of the given ethanoic acid. Now, using this number of moles, we can substitute the answer in the molality formula and then get the answer. So, mass of the solvent in the question is given in terms of gram. We can convert that to kilogram by dividing it by 100. We will get 0.05 kilogram. Now, take this formula, molality formula, and substitute the values. We will get the answer. And it is 0.834 molal. Okay. So, this is how we have to solve. So, this is about the 4 concentration terms that are coming in this lesson. Now, let me summarize the solution part. Okay. So, first, yesterday we have discussed the introduction to the world of solution and we have discussed 4 formulas. One is mass percent. It is mass of solute by mass of solution into 100%. And then the second is mole fraction. It is number of moles of that component divided by total number of moles. And the third formula that we have discussed in the beginning of today's session is molarity. Molarity is denoted by the letter capital M. It is equal to the number of moles of solute divided by volume of solution in liters. JNV Ramnagar students, I think you have missed this. You were not there in the class when I was discussing the molarity, right? Just take down this formula now. Molarity, very important formula. And then coming to the last, molality, it is number of moles of solute divided by mass of solvent in kilogram. So all the four formulas are very, very, very important. Okay, for your class 11 as well as for your class 12. In class 12, you will have one lesson called solutions. Solutions is the name of the lesson. So in that, you will be using this again. All the formulas you will use there also. Okay, so this is very important. So with this, we are completing this lesson, and now we are going to solve some previous year's questions of JN NEET on mole concept and stoichiometry. Okay, so let's start with the first question. In 1 molar solution that contains 0.5 mole of a solute, there is. Can you guys try for this? I'll give you 15 seconds. Just try for this and let me know the answer in the chat box if you have got the answer. Okay? We will discuss. We will discuss. Has anyone got the answer? No. Okay, we will discuss. So we have to option A. Option A is not the answer. Okay, we will discuss. Okay, no issues. Don't worry. So what is molality? Molality means the number of moles of solute in number of moles of solute divided by mass of solvent in kilogram, right? So the number of moles of solute dissolved in 1 kilogram of solvent is nothing but the molality. Now in the question, it is given that 1 molar solution. So molality is already given. Molality is given as 1. Now, 1 molar solution. What is meant by 1 molar solution? 1 molar solution means that 0.5 mole of the 0.5 mole of the solute is dissolved in 1 kilogram of solvent. That is the meaning. Okay. Now, if I take the formula molality and if I try to substitute the values, number of moles of solute divided by mass of the solvent in kilogram. Now we have the m value and it is equal to 1. And the number of moles of the solute is 0.5. We are asked to find out the mass of the solvent. Okay, just take this mass to the other side and we will get 0.5 kilogram. Okay, 0.5 kilogram. 0.5 mole of solute is dissolved in 1 kilogram. So now the mass is coming out to be 0.5 kilogram. But in the question, we don't have a kilogram, right? So we have solvent and the mass of this solvent is 0.5 kilogram. We have answer in terms of gram. So 0.5 kilogram is equal to what? 500 gram. So we have to multiply this by 100, right? 1000, right? So it will be 500 gram of solvent. So option B will be the correct answer. Okay. Ramnagar students, is that clear for all? You have got the answer, but you have found it in terms of milliliter, I think. Just remember this formula. So in the formula, we have kilogram. Okay, fine. So we will move on with the next question. An organic compound contains 78% by weight of carbon and remaining percentages of hydrogen. The right option for the empirical formula. So do you remember the empirical formula that we have discussed yesterday? Can you guys try for the answer? Try for it. So first what we have to do? First we have to write the element given in the question, right? What are the elements? Carbon and hydrogen. Then we have to write the percentage composition. So the carbon percentage is 78 and the remaining is hydrogen. So 100 minus 78, it will be 22. 22% is hydrogen. And then we have to find out, take the atomic mass. Next column is atomic mass. The atomic mass of carbon is 12 and hydrogen is 1. And then Our job is to find out the number of moles, right? What is number of moles? Mass divided by molar mass. So what is the mass of carbon? It is 78 divided by 12. This will be equal to 6.5. And here 22 divided by 1 will give 22. And then we have to find out the simplest ratio. So the simplest ratio, to find out the simplest ratio, what we have to do? Divide the number of moles, all the number of moles by the smallest value. And here we have only two element, D. Very good, JNV Ramanan. D, option D is the correct answer. So 6.5 by 6.5 will give 1. And here 22 divided by 6.5 will give 3.3. So we have 1 carbon and 3 hydrogen. So the empirical formula is C1H3. Option D is the correct answer. Very good. So let's move on to the next question. Which one of the following has maximum number of atoms? Which one has maximum number of atoms? So to solve this, what we have to do? We have to take the number of atoms. So the number of atoms is equal to the mass divided by molar mass into Avogadro number into atomicity. Okay. So taking for this magnesium, so to find out the number of atoms in 1 gram of magnesium, I have to take the mass of magnesium. So what is the mass of magnesium given? It is 1 gram. Option C? Yes, you are correct. Good. Option C is the correct answer. Let us discuss so that others also can understand. Okay. It is 1 gram and the molar mass of magnesium is 24 into Avogadro number. Atomicity means the number of atoms present. So in magnesium, we have only 1 atom. So the atomicity will be 1. And coming to oxygen, the mass is 1 and the atomic mass, the molar mass of oxygen, if you take, actually the atomic mass of oxygen here, it is wrong. It is actually 16. Okay. So 16 into 2 will be 32 into Avogadro number. Atomicity, if you see here, we have 2 oxygen, right? So the atomicity will be 2. So atomicity is 2. Now coming to lithium, 2 means it will be 16 here, 1 by 16. Coming to lithium, it will be 1 by the atomic mass of lithium is 7 into Avogadro number. Coming to silver, it is 1 by 108 into Avogadro number. Okay. Now, the component which is having the least value in the denominator will have the maximum number of atoms. If the denominator is very less, then the answer will be more, right? So if you see, if you compare, here we have 24, 16 and 7 and 108. If you solve this, the one which is having the least number, that is lithium, that will have the maximum value, that is maximum number of atoms. So option C is the correct answer. Option C is the correct answer. Good. So I think I can move on to the next question. So any doubt from this question? Okay. So the next is the number of moles of hydrogen molecules. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's processes. So what is Haber's process first of all? It means it is N2 plus 3H2 giving 2NH3. So this reaction is called as Haber's process. It is used for the manufacture of ammonia. Okay. And here if you see the ratio, 1 mole of nitrogen is reacting with 3 moles of hydrogen and it is producing 2 moles of ammonia. Okay. But now in the question, they are asking us the number of moles of hydrogen molecules required to produce 20 moles of ammonia. So to form the 20 moles of ammonia, how much hydrogen molecules are required? So to find out the answer, what we have to do? Just cross multiply. It is 3 by 2 into 20, right? Very good. The correct answer is we are getting 30. So 30 moles of hydrogen is required. Very good. So option C is the correct answer. Good. Now let's move on to the next question. Yeah, it is a JE question. Okay, that's why this question doesn't contain options. It is the JEE question, okay, which was asked this year, January 2023. They have asked, okay. So on complete combustion, 0.492 gram of an organic compound gave 0.792 gram of carbon dioxide. The percentage of carbon in the organic compound is. So can you try for this? I'll give you 15 seconds. 15 to 30 seconds I'll give you. Try to find the answer. After the 30 seconds, we can discuss in the class. Okay? Try for the answer. Okay. Okay, then we will discuss. So we are asked to find out the percentage of carbon in the organic compound, right? So to find out the percentage of carbon in the given compound, the formula that we have to use is mass of that component, that is mass of the carbon divided by the total mass into 100. So this is the formula we have to use. Okay. Total mass we have in the question because the total mass of the compound is given here. It is 0.49. But we don't have the mass of the component, that is carbon. So what we have to do? We have to find out this term. We have to find out the mass of carbon. Or I can say we can find out the weight of carbon. So the weight of carbon in 0.792 gram of carbon dioxide, it will be equal to the atomic mass of carbon divided by the molar mass of carbon dioxide. It is 44 into 0.792. So this will give 0.216. So this is the mass of carbon. So we can substitute this in the formula. If we substitute, what we will get? The percentage of carbon in the compound will be 0.216 divided by the total mass is 0.492 into 100, and this will give us 43.90 percentage. Okay, this is the answer. So any doubt from this question? So we are taking the formula and finding out the terms which are required from the given information, that is in the question. Shall I move on to the next question? Do any of you have any doubt from this part? Okay. So the next question is, the volume of hydrogen liberated at standard temperature and pressure by treating 2.4 gram of magnesium with excess of hydrochloric acid is some dash into 10 power minus 2 liter. And the molar volume of gas is given, molar mass of magnesium is also given. We have to find out the volume of hydrogen liberated. So let me write the equation first. So magnesium is reacting with HCl, hydrochloric acid. If it reacts with HCl, it will produce a salt, magnesium chloride salt, and hydrogen gases evolve. If I have to balance this equation, I have to put 2 here, right? Yeah. Now the equation is balanced. This is the reaction. Now, to find out the number of moles, of the magnesium, it is mass by molar mass. The mass of magnesium that is reacting with HCl is 2.4 and the molar mass of magnesium is 24, and from this we are getting 0.1 mole. Okay, number of moles of magnesium is 0.1 for the given amount of magnesium, that is 2.4. Okay, now what we have to do, for one mole of the gas, 1 mole of the gas at standard temperature and pressure, it is equal to 22.4 liters. So 1 mole of gas at STP, it is equal to 22.4 liter. Now for 0.1 mole, what we have to do? So for 0.1 mole of the gas at standard temperature and pressure condition, we have to cross multiply this. So 0.1 into 22.4, right? So it is 2.24 liter. Or I can write this, and let me write here. Okay, it is also equal to 224 into 10 power minus 2 liter, right? Because we have to give the answer in terms of 10 to the power minus 2. So take the decimal to the right side. So it will be 10 power minus 2. So the answer is 224. Correct answer is 224 is into 10 to the power minus 2. Is that okay? Any doubt? So for 1 mole, the value is given. We have to find for the required number of moles. Okay. So to find out that mole, mass by molar mass formula is being used from the given information. Is that fine for all? Shall we move on to the next question? Yes. Yes or no? If you are having any doubt, you can ask me. Okay. The next question says that 56 liter of nitrogen gas is mixed with excess of hydrogen gas, and it is found that 20 liter of ammonia gas is produced. The volume of unused nitrogen gases. So it is same as that of that Haber's process. So in Haber's process, what happens? Nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia, right? So this is that reaction. And here, what is the ratio? 1 mole of nitrogen is giving 2 moles of ammonia. Okay, 1 is giving 2. Means in terms of liter, if I want to write, then it is nothing but 10 liter of nitrogen is producing 20 liter of ammonia. Okay, in terms of liter, I will write like this. Now, excuse me. Sorry. So now we have to find out the volume of unused nitrogen gas. That is the volume of nitrogen left in the reaction, or the unused nitrogen gas in the reaction mixture is the total liter of nitrogen gases, it is 56. It is 56. Now out of this 56, to produce this 20 liter of ammonia, only 10 liter of nitrogen is being used. So what I have to do? 10 liter has got reacted from this 56 liter. So 56 minus 10 will give 46 liter. So 46 liter of nitrogen gas is left unreacted. Okay. Clear? Any doubt you have from this? Okay. So we will go with the next question. There are two elements, A and B, which form 0.15 moles of A2B and AB3 type compounds. If both the compounds weigh equally, then atomic weight of A is dash times of atomic weight of B. Okay. So, what they are saying, both the compounds are weighing equally, means the molar mass of both the components are equal. That is, A to B should be equal to AB3. It should be equal to AB3. And question says that A is the atomic weight of A, and B is the atomic weight of B. Okay. Question says like this. Last statement says like this. Option B, Ashira. We don't have any options here, no? Yeah. So here we have, so 2A plus B. 2A plus B. So therefore 2A plus B should be equal to A plus 3B. Right. If I calculate the atomic mass of each thing, it will look like this, and these two should be equal. So 2a, if I take this a to the other side, I will have it is minus a and it is equal to 3b and minus b. So 2a minus a is a and 3b minus b is 2b. So a is equal to 2b. So a is 2 times the atomic mass of B. Okay, the answer is 2. Atomic weight of A is 2 times of atomic weight of B. Is it okay? Clear? 2022 JEE main question. Shall we go with the next question? Yes. The number of nitrogen atoms in 681 gram of C7H5 N3O6 is X into 10 to the power 21. The value of X is, and Avogadro number is given. So how to find out the value? We have to find out the number of nitrogen atom. So to solve the number of nitrogen atom, we need molar mass value and we need the number of moles, right? So first let me write the molar mass. So to find out the molar mass of this given compound, which is C7H5N3O6, the molar mass, if I calculate using the atomic masses of carbon as 12 and hydrogen as 1, and for nitrogen it is 14 and for oxygen it is 16. Now if I calculate using how many carbon I am having, 7 carbon, 5 hydrogen, 3 nitrogen and 6 oxygen. Accordingly, if I multiply by the corresponding number, I will get one answer, right? And that answer is 227 gram per mole. So the molar mass of the given compound is 227 gram per mole. Okay. Then 681. In the question, it is saying that 681 gram of this substance. So 681 gram of C7H5N3O6 will have. So this is for 1 mole. This is for 1 mole. Answer is 3. No. So this is for 1 mole. And 681 will be, if I multiply this 227 by 3, I will get 681, right? So 681 gram of the substance will have 3 mole. This is for 1 mole. 227 is for 1 mole. 681 is for 3 mole. So therefore, 681 gram of the given compound has 9 mole of oxygen. Sorry, nitrogen. 9 mole of nitrogen, because this compound has 3 nitrogen, right? So 3 into 3 will have 9. So 9 mole of nitrogen is present in 681 gram of the given substance. Any doubt till this for anyone? So is everything clear till now for all? So we are getting the molar mass. So molar mass will give us for 1 mole, and we are getting the number of moles from the values given in the question, and from that we are getting the number of moles of nitrogen. Yeah, that's what I'm repeating. Okay, we have to find out the number of moles of nitrogen present in 681 gram of the substance. So that is the first thing we need to find out. So before getting the number of nitrogen atoms, we need the number of moles of nitrogen. Okay, so to find out the number of moles of this nitrogen, we need to find out the number of moles of the compound present in this 681 gram. So to find out that, I'm starting from the molar mass of the given substance first of all. So the molar mass is coming out to be 227, and for 681 it is 3, because 227 into 3 will give 681. Okay, or if you divide 681 by 227, you will get 3. So 3 mole of the compound is present in 681 gram of this compound. Okay, so since we have 3 nitrogen, already 3 mole, 681 gram contains 3 mole of the compound. And if I want to find out the number of nitrogen alone, number of moles of nitrogen alone means I have to take the number of atoms of nitrogen, that is 3 into this 3 is giving me 9. So 9 mole of nitrogen is present in 681 gram of the compound. Is it okay, JNV Ramnagar? Shall I proceed? Yeah. So now this says that 9 into Avogadro number of nitrogen. And to find out the number of atoms, what we have to do? We have to multiply by the Avogadro number, right? So it is 6.02 into 10 to the power 23 nitrogen atoms are present. 9 into Avogadro number of nitrogen atoms are present in 681 gram of the substance. Now, if I multiply this, what I will get? 54.18 into 10 to the power 23 nitrogen atoms. Okay, but we have to give the value in terms of 10 to the power 21. So change this and move the decimal. So it will be 5418 into 10 to the power 21 nitrogen atoms. So what is the X value? X is 418. Okay. Shall we go with the next question? Yes. This is the number of moles. This is the number of, okay. So to find out the number of atoms, we have to multiply the mole by Avogadro number. That's all. Okay. So I'll give you that from number of moles is equal to number of particle divided by Avogadro number. Number of mole is equal to number of particle divided by Avogadro number. This is one of the formula for number of moles. So now we need this number of particle only, right? So to find out the number of particle, it will be equal to n into Avogadro number. So n is the number of mole and that is 9 here, and this is the Avogadro number. Is it okay now? I think it will be clear now. So I'll move on to the next question. Number of atoms. Yeah, again in this question we have to find out the number of particle, that is atom, in 8 gram of sodium. This X into 10 power 23, the value of X is. Atomic mass of sodium is given, Avogadro number is also given. So what we have to do? We have two relations to find out the number of moles. One is n is equal to n by Na. What is this n? This n is nothing but the number of particles. Particles can be atom, it can be a molecule, it can be ions, it can be anything. So this is one formula. And the other formula to find out the number of moles is the given mass divided by molar mass. Given mass divided by molar mass. So since the number of moles are same, we can equate this relation. That is the number of particle 1 by 3 approximately. Okay, we will discuss. And see whether your answer is correct. So number of particles divided by Avogadro number. What is Avogadro number? 6.02 into 10 to the power 23 equal to, what is the given mass of the sodium? The given mass of sodium is, the given mass is 8 gram, right? The given mass is 8 gram and the molar mass is only 23. It is 23. Just take this Avogadro number to the other side. So what we will get? The number of particles, the number of atoms. The particle is atom here. The number of atoms in 8 gram of sodium will be equal to 2 into 10 to the power 23. 2 into 10 to the power 23 and the value of X is 2. Value of X is 2. Okay. Ramnagar, I think you have made a mistake in the calculation, mathematics part. Just to have a look on it. You don't have to change the power of this 10. Just do the calculation. 8 by 23 into 6.02. Okay. Clear? These two formulas are very, very, very important. Okay. You guys should not forget this. Two formulas to find out the number of moles. One is number of particle by Avogadro number and the other one is given mass by molar mass. Okay. So let's move on to the next question. If 80 gram of copper sulfate is dissolved in deionized water to make 5 liter of solution, The concentration of copper sulfate solution is X into 10 power minus 3 mole per liter. The value of X is. So we have to find out the concentration. So we have 4 terms, right, for concentration. One is mole fraction and the other one is mass percent, molarity and molality. Which concentration term we have to use here? And how to find out that? You can find out by seeing the unit. You just see the unit. The concentration unit is mole per liter. Mole per liter is the unit of which concentration term? Can anyone try? Mole per liter is the unit for which concentration term? In today's class only we have discussed. It is the, yeah, it is Zain Viramnagar. You have raised your hand. Yeah, very good. It is the molarity. It is a unit of molarity. So we have to use molarity formula to find out the answer. That's all. So what is molarity? Molarity is equal to number of moles of solute divided by volume of solution in liter. But we don't have the number of moles in the question. So, but we know the formula to find out the number of moles. It is nothing but the given mass by molar mass. Just substitute this in the place of number of moles. In place of number of moles, substitute mass by molar mass, and already liter is here. Volume is given. So just write as it is. So what is the mass of the solute? 80 gram of copper sulfate. So that is the mass of the solute. 80 divided by molar mass. Molar mass of the substance we have to find out. How to find out the molar mass? We can use these atomic masses values and then we can get. So one copper we are having, it is, we have one copper, so 63.54. And one sulfur we have, atomic mass of sulfur is 32. And how many hydrogen? 5 into 2, 10 hydrogen we have, no? So 10 hydrogen. So 10 into 1 will be equal to 10. And how many oxygen? Here 4 we have, and here 5 we have. So 4 plus 5 is 9. So 9 oxygen we have. So 9 into 16 we have to do. Okay. So what is 16 into 9? 54. 144. So we have to use 144 here. Now if I add all these things, we will get 54 here and 5, 9. We will have 249. 249.54 is the molar mass of the compound. Okay. And coming to the volume, yeah, it is given 5 liter. It is already given in terms of liter only. So just substitute the value 5 here. And then if you solve this, you will get just approximately, you will get 64 into 10 to the power minus 3 mole per liter as the value. Okay. So the molarity of the solution is 64 into 10 to the power minus 3. So what is the value of X? Value of X is 64. Okay. Value of X is 64. Nothing to do. You just need to find out the formula. Remember the formula and straight away you have to apply. The only part is to do is the mathematics part. That's all. Just the multiplication and division part you have to do. So that takes some time. The rest all is very easy. Okay. Shall we go with the next question? Yes. Yes. Yeah. The molarity of the solution prepared by dissolving 6.3. Again, the molarity only we have to find out. For 6.3 gram of oxalic acid. So this is the oxalic acid and that is the solute. The given mass of the solute is 6.3 gram. And it is dissolved in 250 ml of water. Volume is given in terms of milliliter. We can convert that into liter. And it is mole per liter is X into 10 power minus 2, the value of X. So it is same as that of the previous question only. Okay. So we can use the molarity formula. Molarity formula is equal to number of moles of solute divided by the volume of solution in liter. Right. So we don't have the number of moles. So what we have to do? We have to do mass by molar mass into volume. So what is the given mass? 6.3 divided by molar mass we have to find out. We have 2 hydrogen here and 2 to 4 hydrogen here. So 2 plus 4 is 6 hydrogen, so it will be 6. And we have 2 carbons, so it will be 24. And how many oxygen we have? 4, 5, 6 oxygen we have, no? So for 6 oxygen, 16 into 6, how much? 96. So we have 96. So what is the value? It will be 126. So the molar mass is 126 into the volume. Volume is given in milliliter. No, we have to convert this into liter. So we have to divide by 1000. 250 divided by 1000 will have, and the denominator of the denominator goes to the numerator. So we can just cancel out this easily. It will be 4, and still if we solve this, 2, 6 and 3 here, and again here we will have 0.1, 0.1 into 2 is equal to 0.2 molar. So this is the answer. But we have to find out in terms of 10 to the power minus 2, right? So 10 to the power minus 2 means you have to multiply this by 100. So we will have 20 into 10 to the power minus 2 mole per liter. Okay, 20. 20 is the value of X. 20 is the value of X. Okay, clear? Same as that of the previous question. You need to concentrate on the unit and the decimals. Okay, fine, good. So let's go on with the next question. 8 gram of sodium hydroxide is dissolved in 18 gram of water. Mole fraction of sodium hydroxide in solution and the molality of the solution respectively are. So what we have to do? To find out the mole fraction and molality, first let's do one by one. To find out the mole fraction, what we need? The first component, A component, is sodium hydroxide. And the B component is water. Okay. I have to find out the mole fraction of sodium hydroxide. XA I have to find out. For that, what I need? It is Na by Na plus Nb, right? I need the number of moles of sodium hydroxide as well as the number of moles of water. Whether it is given in the question? No, it is not given in the question. I have to find out. How to find out the number of moles? Mass by molar mass formula we have to use. Okay. So, the number of moles of sodium hydroxide is equal to the given mass of sodium hydroxide. It is 8 gram divided by molar mass of sodium hydroxide. So, to find out the molar mass, take the atomic mass. For sodium, it is 23. For oxygen, it is 16. For hydrogen, it is 1. It will be 40. 40 is the molar mass of sodium hydroxide. So, this will give 0.2 mole. And to find out the number of moles of water, the mass of water is 18. Molar mass of water will be 18. Okay. 2 and 16, no. So, it is 18. So, 18 by 18 is 1 mole. So, we have got Na and Nb. Just substitute in this formula. So, the mole fraction of sodium hydroxide is equal to Na 0.2 divided by 0.2 plus 1. Okay, it will be equal to 0.2 divided by 1.2. Okay, so this will give us the value. This is the mole fraction. And then we have to find out the molality. So what is the formula to find out the molality? Number of moles of solute divided by mass of solvent in kilogram. Mass of solvent in kilogram. So let me just erase this side. Let me just erase this. Okay. So the formula molality is number of moles of solute by mass of solvent in kilogram. So the number of moles of the solute, NaOH is the solute, and the number of moles of the solute, NaOH is 0.2 divided by mass of the solvent. So this is, water is the solvent. Mass of the solvent should be represented in kilogram, but it is given in terms of gram. So what I have to do? I have to divide this 18 by 1000. So that goes to the numerator. That goes to the numerator. Very good, Hashira. The answer is 11.11 molal. Molality is equal to 11.11 molal. Good. Good, good. Yeah. So I think we can stop this today's session here. I hope the session is very useful to all of you. Just read all the formulas and solve questions and try to apply all the formulas that you have studied and practice more number of questions like this. Okay, take all the previous year's questions and try to solve one. Okay, don't just get scared on seeing the physical chemistry questions like this. Okay, find out the values, think and apply the formula and get the answer. Clear? So in the next session, we can meet up with a new lesson. Till then, take care and bye-bye. Thank you so much for listening to today's lecture. If you're having any doubts, you can ask me now or in the next class. Okay? Okay, dear students. Thank you.